Hey guys, we're going to be continuing with Chapter 9, Section 5 here, where we're looking at exploring similar solids. So what you're going to be learning is to use proportions to find missing measurements of similar solids, including surface area and volume. I need you to pause and copy down this one vocab word. Two solids are similar solids if they have the same shape and if all their corresponding dimensions are proportional. Did you hear the one about the talking cow that didn't kill anyone? Neither have I. This is my favorite internet meme of all time, by the way. All right, so finding dimensions of a similar solid says the two pyramids are similar, find the value of x. This is just like similar two-dimensional figures where I could take the value of the larger one and put it over top the smaller one or vice versa. It doesn't matter. But this part right here is going to correspond with this part, and this part right here corresponds with that part. So I'm going to take this value and put it over top of the 6. And whatever that is should equal the same ratio as 12 over 5. All right, so we're going back to our cross-multiplying stuff that we used to do. This is a pretty simple one to solve. Just multiply both sides by 6, and you get x equals 72 over 5, which is the same thing as 14.4 centimeters. So the length of x right here is 14.4 centimeters. Again, that's just using proportions. The big thing for you is just going to be making sure that you set it up correctly. All right, remember cross products are equivalent is another way you could have got to this. 6 times 12 is 72 divided by 5. That would have worked as well. All right, so here's one for you to try. I encourage you to draw the picture so you have a visual. The answer will be up in 3, 2, 1. All right, so here is what I got. Check your answer against mine. That shouldn't have been too bad for you. Let's keep moving here. All right, this is an important slide. You want to make sure that you copy this down so that you could refer to it. Has to do with the surface area and volume of similar solids. It says, if the ratio of the corresponding dimensions of a similar solid is A over B, then the ratio of the surface area is A squared over B squared. That's because you're dealing with a two-dimensional space, an area. And the ratio of the volume is A cubed over B cubed, and that's because you're dealing with a three-dimensional space. So pause and make sure that you copy this down because you're going to need to refer to this. All right, it says the surface area of the cylindrical pitcher is about 90 inches squared. Its volume is about 157 inches cubed. The pitcher and creamer are similar. Find the surface area and volume of the creamer. So the first thing that we need to do is figure out that A over B, what we were just looking at that other slide. So I could do the creamer to the pitcher is going to be 3 to 6, right? So that's creamer to pitcher equals 3 to 6, which simplifies to 1/2. So the ratio of the length of these two different things is 1/2. Now, the first thing it tells me to do is to find the surface area. Well, if you recall, the surface area is given by A squared over B squared, which is going to be 1 squared over 2 squared, which equals 1 to 4. So the ratio for the volume is going to be 1 to 4. So the way that I do this to find the surface area of the creamer, I would say the surface area divided by 90, this comes from the problem up here, surface area of the pitcher is about 90, should have a ratio of 1 to 4. All right, so the surface area should be 1 to 4. So if I divide both sides by 90 and then divide by 4, so 90 times 1 divided by 4, the surface area of the pitcher equals 22.5 inches squared. All right, so I could find that very, very quickly by just using this proportion, okay? I'm finding basically what is 1/4 of 90. To find the volume, that's going to be a little bit different in the sense that it's a cubed over b cubed. So that's going to be 1 cubed over 2 cubed, which equals 1 over 8. So to find the volume of the creamer, I'm going to use my proportion. So the volume for my creamer over the volume of the pitcher should equal a ratio of 1 to 8. So again, I multiply both, cross multiply, then divide. So 157 divided by 8 is equal to 19.625 inches cubed. The big thing here is just going to be remembering to do this. Finding the ratio is not going to be too difficult, but when you're doing surface area, you square them both. When you're doing volume, you cube them both. All right, so make sure you copy all of this down. This is a very, very important slide because I could, kind of looking into the future, if you will. This is going to be somewhat confusing for some of you. So go ahead and pause and give this one a try. The answer will be up in 3, 2, 1. All right, here are the answers I got. Surface area 486 inches squared, volume of 729 inches cubed. You might have got something different than that. I just want to point a couple things out. First of all, I just wrote out for this one, that's my surface area. For this one, that's my volume. I just go ahead and write these ratios out so that I have them in front of me. The other thing to consider here is that the ratio of 1/3 is going to be the smaller box to this larger box. I have the surface area and the volume of the smaller box. So if it's 1/9, then the smaller box value needs to go on top. And the surface area of the larger unknown box is going to go on the bottom to match with the smaller to the larger. Same thing with down here, the smaller to the larger. So I have the smaller box's volume over the larger box's volume. I just cross multiply these, so 54 times 9 divided by 1 is where that comes from. 27 times 27 divided by 1 is where that comes from. So try to go back. If you didn't get that right, go back and try to figure out maybe where your mistake was. Hopefully I just pointed it out for you. I believe that's it for today. It is. So hopefully you took good notes. I will see you all in class.